All right, guys, so let's do some problems with the Riemann sum. So here is an example. Say we want to estimate the area under the curve y equals 1 plus x squared from 0 to 4. So that's saying the integral from 0 to 4 of 1 plus x squared. And that's using two rectangles. Okay, and we'll say we'll do this with a left sum and a right sum. So here I didn't give you a graph, I just gave you an equation instead. But what you want to do is first off, just split it into two intervals. So if I'm going from 0 to 4, if I cut that in 2, the midway point is 2. So my intervals are 0 to 2 and then 2 to 4. Okay, so if I do a left Riemann sum, I'm using the left endpoint at each. So I still use the height at the left endpoint. So I'm still setting this up. They have a base of 2, so I'm going to have 2 times the first left endpoint, and then from 2 to 4, I have 2 times the next left endpoint. Now, to find those values, I'm just going to need to plug in this formula right here. So I'm plugging into the curve. That's what I'm trying to integrate, find the area under. So f of 0, of course, is just 1, and f of 2 is equal to 1 plus 4 is 5. So this is just 2 times 1 plus 2 times 5, which is 12. Okay, now for the right Riemann sum, we're again going to do the same thing. We're just going to be using the height at the right endpoint. I just realized I'm doing left in blue and right in red. That's actually pretty funny. Okay, so for the right Riemann sum, we use the height at the right side of each interval. Okay, so we're going 0 to 2 and then 2 to 4. Okay, so we use the height of the right side of each one. So we have 2 times f of 2 and then 2 times f of 4. Try my strategy. When you write out the intervals, like circle the parts that you know you're using, the left or the right. It'll help keep you in mind of which one you're trying to do. All right, so anyway, that's 2 times 5. F of 4 is 1 plus 4 squared is 17. So that becomes 44. Okay, now anyway, let's get to a table, because this is honestly the most common application of a Riemann sum that you're going to see on the AP test. They'll give you a table and ask you to estimate some integral using a left Riemann sum. And the intervals are just what's going on between each point. So my intervals are going from 0 to 3, and then 3 to 5, and then 5 to 6, and then 6 to 10. Now, one thing you're going to see within these intervals is that the bases change, right? This one has a base of 3. This one has a base of 2. This one has a base of 1, but this one has a base of 4. But don't let that scare you off. Like, it's still the same thing. We have different bases, sure, but if we're using a left Riemann sum, we're still using the height at the left endpoint of each of those. So I use the height on the left, and again, I'm adding together a bunch of base times height, so that's like 3 times f of 0 plus, okay, the next interval is 2 times f of 3, 5 to 6, we have 1 times f of 5, and then 6 to 10, we have 4 times the height at the left endpoint there, which is 6. And then when we get these values, now I'm going to get these values from the table. So I'm going to just plug in from the table to actually help get these values of f right here. Okay, so when we do that, we're going to have 3 times 5, then we're going to have 2 times 7, and then we're going to have 1 times 3, and then we're going to have 4 times 2. Okay, that's 15, 14, 3, and 8. That worked out nicely. It's just 40. Okay, cool. Now, I'm not going to do the math, but I'm going to do the setup for right Riemann sum. If you want to pause the video right now and try it on your own, that might be a good idea. Okay, so on the right Riemann sum, we have the intervals here. And they're the same intervals and the same bases, of course, but now we're using the height on the right endpoint. Now, I'm not going to work this all out, but your setup should be like, okay, so I have 3 times f of 3, and then here I have a base, this is base and height, and then I have 2 times f of 2, not f2, f of 5, and then from 5 to 6, we have base of 1 times f of 6, 6 to 10, we have 4 times f of 10. All right, so that's the setup for that, just plug it from the table. Okay, now you might say, hey, we could go left, we can go right, but wouldn't it be better to go somewhere in the middle? Like, would that be a better estimate? And you can. So this is called a midpoint Riemann sum. And basically what you're doing with a midpoint sum is you use the height in the middle of each interval. So just pick the point, like set up your intervals, and then say what point is in the middle of each of those intervals. Okay, so let's see, we have 0, so if we're still trying to do the same thing, we're trying to estimate from 0 to 8, and then we cut it up at 4. So my intervals here would be 0 to 4, and then 4 to 8. So if you want to find the midpoints of each one, you're just finding, like, what's the average between the two endpoints? So halfway between 0 and 4 is 2. Halfway between 4 and 8 is 6. So when I sit up and I do my base times height for each of these, and of course my base is still 4. When I do that, let's see, so I'm still doing base times height. So I'm doing 4 times the height at the middle, so 4 times f of 2. And then 4 to 8, I'm using the height of the middle, which is f6, so 4 times f of 6. Now, graphically, what this is doing is saying, okay, here's my interval. So the middle of this interval is 2. So I'm going to use the height at 2. Use that, and then just draw the rectangle in both the directions to the side, and use that area. So you can see this a little better, right? It underestimates a little here, it overestimates a little here, but it's probably a little better than the left and the right Riemann sums. Not always, but in a lot of cases. Okay, and then 4 to 8, we can do the same thing here. We use the height of the middle, so we use the height at 6. Go up to the function there, and then go across, so that's 4 times half. So anyway, that'll give you a value of 18. All right. So one more thing we could see, and again, feel free to try this on your own right now if you want, and pause me. So now we say estimate the area under the curve 1 plus x squared from 0 to 4 using 2 rectangles with the midpoint sum. Okay, so again, I write out my intervals. I'm going 0 to 4, I cut it in 2, so I cut it halfway in the middle. So my intervals are 0 to 2, and then 2 to 4. And of course, each of these intervals has a base of 2. Now, the midpoints of each one, well, what's in the middle of 0 and 2? My midpoint is x equals 1, my midpoint here is x equals 3. So when I do base times height, and add those together, I still have a base of 2 for each of these. So that's just going to be 2 times f of 1 plus 2 times f of 3. So I'm just saying, what's the point in the middle where you use that? Okay, so f of 1, so that's like 2 times 1 plus 1 squared is 2. And then f of 3, 1 plus 3 squared is 10. So that gives you 24. Okay, now one thing I wanted to say, you will never have to pick a strategy on your own, on the AP test, on your test, on anything I'll give you. I will always tell you which one to use. So either use the left, use the right, or the midpoint, depending on what the problem says, and you'll just do whatever it says. You won't have to come up with that on your own. I just wanted to share all 3 with you today. Okay, we'll bring some questions if you got into class, and I'll see you all soon. Thanks for watching.